Hello, thanks for joining this online session. I'm Soflen Shih, located in Taiwan, working in Intel software and service group as a technical consulting engineer. So one of the toolkits developed by my group is named Intel System Studio. This toolkit has several functions, can help IoT product development and accelerating the time to market. But in this session, I want to focus on introducing the debug ability provided by our tool. So let me switch to my slides. Here's the title. The upcoming version of Intel System Studio. Here, System Debug and System Trace are the debug tools for analyzing the issues which happen in boot sequence. In Intel 64 and IA32 architecture, boots into the OS. I will quickly go through what Intel System Studio is and what it has. Then show you hardware connectors or called props, which is for connecting your host PC to a target platform. Thirdly, I will brief a new connection feature in 2018 called Target Connection Assistant. Then we will get into our major topic, our two debugging tools, System Debug and System Trace. The tools of Intel System Studio can be categorized into three types: compiler and libraries. We offer C and C++ compiler, multitask accelerating libraries, signal processing library, and math library to help programmers squeezing CPU and GPU's computing capability. The second category is analyzers. During the product development phase, power and performance tuning is always a thing, needs tons of working hours. Intel's duration of a CPU in each C state and can analyze your software application to find some inefficient code. The last category is debuggers. Includes System Debug, System Trace, Intel Debug extension for Connection Assistant. With these debugging tools help, users can find ME BIOS issues or Windows hand issues by their own. Connection Assistant is for helping these three tools. Three major debugging tools in System Studio, but in this session, we only focus on System Debug and Trace tools. As mentioned, System Debug is for UEFI BIOS debugging in source level. System Trace is for real-time collect BIOS messages. I will talk about them later. Here's a free download link to get Intel System Studio 2018 beta version. In the installation, you can see a bunch of tools will be installed. The bottom one, Intel System Debugger 2018, is the package which includes System Debug and Trace. Now, let's see what those hardware connectors are. The first one is the oldest one in our support list. It's called ITP-XDP3. It goes JTAG interface to connect to the target CPU directly. With this prop, user can have a debug connection to Bay Trail, Churchill, Skylake, and Kaby Lake. From the photo, you can see it attached to a JTAG socket on the board, which means customers have to remove the case and mount a JTAG connector onto the board. Moreover, the price is not friendly at all. That's why Intel created another debug interface on PCH. This debug interface is named DCI, stands for Direct Connect Interface. A blue box named CCA is required to connect the host PC and the target platform. Different from JTAG, there's no need to remove the case from product for setting up a DCI connection. It works on the normal USB 3 port without redriver nor USB hub. But this DCI function requires PCH support, so it only works on Skylake, Kaby Lake, and the newer big core platforms. And you can see the price is acceptable. To make more customers have wheels to use our debugging tools, Intel provided a new probe with more friendly price. It's a USB A2A cable with the same DCI interface. It supports Upper Lake, Kaby Lake, and the newer big and small core CPU. Unfortunately, there's always a but behind good things. This USB cable relies on USB protocol ready. Thus, it's not the best choice for some early stage debugging before USB has done the initialization. From this timeline chart, very powerful to show its debugging ability at the first place. Then, the closed chassis adapter starts working right after ITPX DP3. And here, you can see the USB debug cable wakes so late. It's even behind CPU ready. The good news is Intel will support a USB 2 as DCI interface on the next generation platforms. You can see the ready time of USB 2 is much earlier than USB 3. And regardless of a PMC debugging, the USB 2 has the same capability as a CCA, the blue box, on CSME and BIOS debugging, showing the current available props in our support list. With this, Intel System Studio is able to send commands to CPU and PCH for asking debug function support. Okay, before the main dish, allow me to serve you an appetizer. It's called Target Connection Assistant. It's a new feature in Intel System Studio 2018. So the purpose of this Eclipse add-on tool is to help users to easily configure the connection to the target. So this slide shows how to launch Target Connection Assistant. After installation, there is a shortcut in the Start menu for user to launch TCA. User can create a new connection by following these steps. Then, a connection dialog will jump out. In the dialog, user needs to decide the target platform first. Then, the dialog will show available hardware connectors with pictures to users. Before using System Debug or Trace, user has to select a configuration from the list and click the connection button. So, yeah, that's what Target Connection Assistant looks like. Now, let's see what features that System Debug can provide to BIOS developers. System Debug is a BIOS source level debugging tool user can have step-by-step debugging with a run control. They can also set hardware or software breakpoints at the place where they want to start code tracking. When users build EFI BIOS code in debug mode, it generates symbol files. And meanwhile, the symbol information and address offset table will be added into the BIOS image. It makes users able to load the symbols for showing the C code in system debug. The tool also provides developer a function to do system management mode debugging, or called SMM mode debugging. Moreover, the function to read the content of a PCI registers also helps user a lot. After user clicks the connection button in the target connection assistant, he or she can launch system debug by clicking this icon or navigating to it. In system debug, one more step is needed to set up the physical connection to the target platform. If everything works well, it will show initialization complete in console view. Then, user can see assembly code and see run control buttons become visible. By pressing those run control buttons, user can step to next in assembly code. User can ask CPU halt and halt or keep running, and can reboot the target CPU if want. This chart shows the UEFI boot sequence. In the sequence, SEC and the PEI code is loaded into flash memory. Their addresses are fixed when user installs. So when user loads symbol file, can load it in any phase. So the Intel CPU supports 4 hardware breakpoints. The addresses of the hardware breakpoints are stored in registers. CPU is forced to pause at these addresses. Contrarily, the user can create unlimited software breakpoints. The addresses of software breakpoints are managed by tool. So when the system is busy, the process may not stop at the breakpoints or slip through the breakpoint and stop behind it. There is one special breakpoint in system debug. It's for system management mode, or called SMM mode debugging. We all know this SMM mode is a special mode for CPU to deal with some particular jobs like power management and critical error handling. In the most of time during the BIOS boot sequence, CPU processes in a normal mode. But when CPU receives a system management interrupt, it will jump to SMM mode and start handling. When the CPU receives the SMI or its system management interrupt, it will jump to a SMM mode and start handling the emergent situation. But the code inside SMM mode is protected. When CPU is running in the normal mode, there's no debug tool can access the data of SMM zone. The SMM address and the data is only accessible when the process is in SMM zone. Therefore, we need a breakpoint at the entry of SMM zone. When the CPU gets SM interrupt, it will stop at the entry. User can get into the SMM world after several times clicking next step, and then the user can start debugging the SMM code. So these two slides, this one and these two slides show the steps to create an SMM entry breakpoint in the tool. And you can see the access to MSR 9A code is prohibited before getting into the SMM mode. It's because the MSR 9A code records the address of SM base. But after we triggered SM interrupt and the process stops at the entry, we can read the content of SM base. The last feature I want to introduce is PCI scanning. By clicking the PCI button and the scan button, user can easily get the content of all PCI registers. It can benefit the developers who is working on PCIe wide card issue or other device issue related to PCI bus. The last tool is System Trace. System Trace is for capturing ME, BIOS, and some power-related messages. The usual way to get BIOS logs is to wire out a serial port and get logs from UART. But it's only for BIOS messages. System Trace collects ME and BIOS messages with timestamps and put them together in sequence. It's much easier for user to understand an issue is caused by ME or by BIOS. After capturing the logs, users can analyze the logs by themselves or pass it to some other experts. So the feature to import and export trace log are also necessary. The feature to filter and highlight function is for assisting users to analyze the logs, picking up the messages from trace logs by searching some keywords, make users easier to find the clues to problems. The event distribution is a visible chart. It's a visualized chart showing when those messages arrive. User can tell messages come in bursts or periodically with these charts help. Okay, this slide shows how System Trace collects BIOS, ME, PMC, and the system event messages. Actually, it relies on a feature in PCH named Intel Trace Hub. The Trace Hub collects messages from software, firmware, and hardware sources. It adds timestamps for every coming messages and output messages to users host PC via DCI. Here shows how user launches System Trace. It shares the same path with a target connection assistant. When getting into Eclipse, one more step is required to load System Trace perspective. So please follow the steps here to load the perspective. And after the loading the perspective, the system trace will look like this. And it also needs a target connection assistant to establish a connection to a target platform. Once the connection is set, the capture button will become enabled for users. This slide shows how to capture messages. The default use case for debugging is to start capturing first, then try to replicate the issue. When the issue happens, maybe it's a black screen or a hand issue. Press the Start button to get the whole trace logs for analysis. If an issue happens on the production line in a factory, local engineers can help to fetch logs and export the logs into a file. Then mail it to backend BIOS or ME team for analysis. When the BIOS or ME team receive the log file, they can import it into system trace and open it. After they open the log file, they can search or filter some keywords to extract useful messages from the logs. The visualized event distribution can help developers to understand how those messages come. Is it periodical or come in bursts? Does it match the period of a standby behavior, or those messages were triggered by some event? So this event distribution provides another perspective to users for debugging. That is quite helpful to realize the system behavior based on the timeline view. Okay, the last slide has several useful links. We have links for you to download Intel System Studio 2018 beta version and the Intel System Studio 2017 trial version. There are some online documents on Intel Developer Zone. And if you need a prop, here's the links to redirect you to our online store. So that's all my presentation about system debug and trace. Do you have any questions? Okay, so I got a question from Muthana. What's the important part in IoT as a thesis? So yeah, it's to me, because I'm a debugger tools engineer. So in my opinion, that would be enabling and how to make sure the device, the IoT device, has a good stability to longevity its life, its a battery life. Yeah. So the tool can help the previous the early stage to help developer debug the like a boot up or the enable. Yeah, SMM, how can help in operations? So Sabarinath, sorry, it's difficult to pronounce. So he asked SMM, how can help operations? So I assume you're asking how to help can help in OS, right? Or in the how it works for the BIOS. So assume you're talking about actually my question is IoT backup. Okay. Sorry, I'm not quite understand the question. He said this question is about IoT backup. You want to know if the backup like solution can be added into the SMM mode, right? Which means when the system knows it's going to crash, so it will back up its data to send to the network or to save it in storage. Is that your question? If SMM can support that kind of a function. So SMM, it's like I said, it's a protected zone. So it's the space for SMM is limited, and it's difficult to put the driver like or wireless or network driver into the SMM mode. But it's possible to save some important data in Flash or in that SMM mode, but it's very limited. So if your IoT device collecting a bunch of data, so it's maybe it can save a few important stuff inside the Flash, but it cannot be the whole data. And it depends on the BIOS team to implement those into the SMM function. So, but in the server, the server product, it's doable to back up stuff when some crash or serious emergent issue happen in SMM mode. Yes. Hope it answered your question. Oh yeah, he is asking if Intel CCA can be used for this. So assume he is saying if he is asking if the CCA can help transferring data to backup, to do backup. No, CCA is for debugging, and it uses a DCI connection. And honestly, this connection, the data rate of this connection is not a very high speed as normal USB 3. So it's not for the purpose of a CCA is not for data transfer. DBC is actually if we connect the CCA and the DBC to the target simultaneously, CCA can use for control to send the control commands, and the DBC cable can be used for can enable the target's DMA to massive transmission. So in another tool called WinDBG extension, we use that to do the kernel dump. So because the kernel dump is like 6 or 4 gigabytes data, it needs the DBC's help to send to have a transmission. So yeah, DBC can be the solution, but so far, like I said, DCI is for debugging. So the backup, it needs some programming effort to enable this backup solution. Thank you for joining this session. Okay, bye.